skill training video has been produced by SEMCA in collaboration with PSSC and CNK. This video is aligned with the job role Supervisor Street Light Installation and Maintenance, QP code PSS/Q2101, NOS code PSS/N2101. We are now going to learn the step-by-step procedure for inspection, testing, glanding and crimping of cable. Inspection and testing of cable. Often a cable fault can be seen well before it becomes an actual problem. A visual inspection of all the cables in your facility is a great way to find trouble before it causes you a downtime. We look for corrosion on the conductors, cracks in the insulation, moisture on the cables and many other indicators of damage to the cables. Cable faults cost money and create disruption. So there is an enormous demand for cable test techniques to ensure that cables and joints are in good condition and help cable faults to be located rapidly. Cable testing is done to predict and then deal with faults. A cable fault is a vital concern for all those involved with the distribution of electricity. A wide range of test techniques and test equipment are available to allow this concern to be effectively addressed. Visual and mechanical inspection. 1. Compare cable data with drawings and specifications. 2. Inspect exposed sections of cables for physical damage and correct connection in accordance with a single line diagram. 3. Inspect for correct identification and arrangements. 4. Inspect jacket insulation and condition. Electrical tests. Continuity of cable. Continuity testing of protective conductors is normally carried out with an instrument able to generate a no-load voltage in the range 4 to 24 volt DC or AC with a minimum current of 0 to ampere. The most common continuity test is to measure the resistance of protective conductors. Polarity test. Polarity test must be done to verify that all such devices are connected in the phase only. Incorrect polarity results in parts of an installation remaining connected to live phase conductors even when a single pole switch is off or an overcurrent protection device has tripped. Now you're watching we are doing polarity test. First we have to ensure that power supply is in off condition. With the help of a multimeter, we are checking terminal voltage showing 0 volt, which means there is no voltage across the terminal. Now we are removing the light fixture and laying wire from phase terminal of light fixture up to switch terminal. Then between phase wire and switch incoming point we will see continuity. As we are seeing when miniature circuit breaker MCB is on, then it is showing continuity, and when it is in off condition, it is not showing continuity. Means polarity is proper. Insulation resistance. The insulation integrity is critical to prevent electric shock. It is generally measured between live conductors and between each live conductor and earth. You are seeing we are doing insulation resistance test between phase and earth at 250 volt DC. We have connected the Mega Red probe with red color phase wire and the Mega Black probe with pole body. Now we are selecting Mega at 250 volts and pressing the test button. Value coming around 5 gigaohm. Now we have connected the Mega Red probe with black color, neutral wire and the Mega Black probe with pole body. Now we are selecting Mega at 250 volts and pressing the test button. The value coming more than 5 gigaohm. The above value shows that insulation resistance is good and the circuit is fault free. Cable and conductors terminations. Before cable termination, it involves cable glanding and cable crimping. Now we will see step-by-step process for cable glanding. Our cable size is 3.5 core, 25 square millimeter, for which we are using gland of 28 millimeter in size. For fixing gland at panel base plate, we have made 28 millimeter size hole through hole saw cutter. We are measuring the cable from the base plate to the termination point with some extra margin. Now we are removing the outer and inner insulation sheath and armor of the cable. Now we will fix the gland. First we are putting compression nut. Now we inserted gland body. Now inserting clamping ring. Now inserting armor clamping cone. The armor cone part will be at the cable armor. Therefore, as per armor cone size, we are measuring the length of armor and accordingly, we are removing the outer sheath of the armor for fixing the armor's clamping cone at the armor. Now we have placed a gland armor clamping cone at the cable armor. Now we are inserting the nipple entry part. Now we are connecting each part and ensuring proper tightness with the help of a monkey plier. Now finally we are tightening the compression nut with the use of a monkey plier. Now we are inserting the cable in the panel through a base plate hole made for the gland. Now we are inserting the final check nut of the gland which will tighten properly with the panel gland plate. By this way, a cable glanding completed. Now we will see step-by-step process for cable crimping. Now we will fix the lug in each conductor with the help of crimping tools. But before that, we will see different tools for cable lug fixing. This is a hydraulic crimping tool. Now you are seeing a crimping terminal of size 25 square millimeters. As our cable conductor size is 25 square millimeters, therefore we have selected a 25 square millimeter crimping terminal. Now you are seeing 25 square millimeter lug for phase and for neutral, which is 16 square millimeters in size. We will use a 16 square millimeter lug. With the help of a wire stripper, we have removed the conductor insulation of the appropriate size. Now lug will be inserted into the conductor. Now we are inserting a lug in each conductor as per size. Now we are inserting a crimping terminal of the appropriate size in a hydraulic crimping tool. Now we have placed the yellow phase conductor with lug into the crimping terminal and now pumping the crimping tool. Now you can see crimping of yellow phase cable lug completed. Now the same way we will do crimping of remaining phase and neutral.